Welcome learners. Today we're going to look at extraction of metals, and particularly going to look at the extraction of sodium. Now sodium occurs as a rock salt, which is solid sodium chloride, which is the main ore, or dissolved sodium chloride. Now sodium is extracted by electrolysis of molten sodium chloride by Downs process using a Downs cell. The diagram below shows a Downs cell. Now a Downs cell consists of iron shell lined with fire bricks on the outside. Now the role of the fire bricks is to maintain high temperature so that the electrolyte does not crystallize. At the center of the cell we have this graphite here, this graphite. Now the reason why the anode is made of graphite is because graphite is not even at high temperature, hence cannot react with chlorine gas. Now sometimes we are told what will happen if the anode is made of steel. Now at high temperature, steel will react with chlorine gas too. Now the cathode is made of steel. This is the cathode here. So it's made of steel. Then we have this what we call the steel gas cylinder, or it's called to prevent recombining of sodium and chlorine because both of them are reactive elements. The melting point of sodium chloride is 800 degrees Celsius. Now, to maintain a temperature of 800, you require high cost of electricity. Hence, the process becomes uneconomical or it becomes expensive. Therefore, to lower the melting point of sodium chloride, molten sodium chloride is mixed with calcium chloride. The role of calcium chloride, it is an impurity, hence lowers the melting point of sodium chloride from 800 to 600 degrees Celsius. Now, the significance of lowering the melting point is it makes the process economical or less expensive. Reason, because it saves on cost of electricity used for heating. Now the reaction takes place in this cell here. We have how many? We have 3 ions inside here. We have calcium ions, chloride ions, and sodium ions. Chloride ions migrate to the anode here. When they migrate to the anodes, they lose electrons as shown below. 2 chloride ions, liquid, arrow, chlorine gas, plus 2 electrons. Now the gas formed escaped through this point here. It's called the hood. Then sodium ions and calcium ions migrate to the cathodes at this point here. Because sodium is below calcium electrochemical series, then sodium becomes preferential charge to calcium ions. The equation becomes as follows: 2 sodium ions, liquid, plus 2 electrons gives you 2 sodium liquid. Now sodium is obtained in liquid form because it has low melting point in the electrolyte. Now after it's been formed here, it is collected on the upper part of the cell here. The reason, because it has low density than the electrolyte. Now the impurity in the sodium collected is calcium. How is it removed? During cooling, calcium crystallizes out first, leaving liquid sodium. The properties of sodium include they are easy to cut, it has low density, has metallic luster when freshly cut, is a good conductor of electricity and heat. Chemical properties include it reacts with chlorine gas to form sodium chloride, which is white fumes. Next, it reacts with dilute acid explosively. 3. It reacts cold water to form sodium hydroxide and hydrogen gas. 4. It burns in air with a yellow flame to form a mixture of sodium oxide and sodium nitrate. Now, uses of sodium include alloy of sodium and potassium is used as a coolant in nuclear reactors because the alloy is a liquid at room temperature. Sodium vapor is used in street lights, which give a yellow-orange light. It is used also in manufacture of sodium cyanide, which is used in extraction of gold. Learners, in the next lesson, we're going to look at the extraction of lead.